You multiply it by what? Uh-huh. Okay, so for the first one, we'd multiply by root 5 over root 5. That's what is rationalizing. And then what's on top? Yeah, so it's 1 times root 5, which is just root 5. It'd be 1 square root 5, or just root 5. Oh, okay. And then on the bottom, square root 5 times square root 5 is square root 25, which is 5. And so that's the answer. It has now been rationalized. And if you compare the decimals, if you have 1 over the square root of 5, that's the decimal. And if you have the square root of 5 over 5, it's the same decimal. So it still equals the same thing, it just in math is considered to be more proper. Some mathematician somewhere said, it is not proper to have a square root on the bottom, so we must rationalize it. And everyone went, huzzah, that's right. And now we all have to do that. It's just like somebody in English said, we should capitalize the first letter of every sentence. And everyone said, huzzah, you're right. And now we do that. Same thing. Okay. So go ahead and work on your warm-up. Fix it. Rationalize all of those. Simplify them. How are the brains? Are the brains good? So 1 and 2 just, okay, yeah, made sense. And then number 3 went, ooh, it's a 2 over 6. A 2 over 6 can be reduced. Did everyone reduce their 2 over 6? Yeah, so the 2 over 6 can be reduced. Oh, I see what you did there. You reduced. Okay, and then 4 is 4. And then you get to number 5 and you go, ooh, those 5s can cancel. I see what you did there. I see what you did. And you get to number 6 and you say, oh, 6 divided by 3 is 2. I see what you did. We get some reducing. Everyone get some reducing on number 6? Yes, yes. Yes, Miss Rice, we did. Marvelous. All right, and then number 7. Did we get number 7? 15 over 10, that fraction. Don't worry, Hannah, nobody saw. Oh, that was funny. 15 over 10, everyone got that? And then number 8, the curveball. Everyone know how I got the 12 on the bottom? So root 6 is 6. 2 times 6 is 12. We good? Okay. The reason we did this warm-up is because we're going to be all this math that happened on this warm-up is math that's going to happen today. So are we comfortable with all the math that happened on the warm-up? 600?
I'm like a 6. I'm trying to say 6 and 7 at the same time. I'm like a 7 out of 10.
Okay. I mean, that's a solid C, so that's good. It's average. Okay. All right. Let's move on to our constructing the unit circle notes. We're taking a flashback to Math 2. Another flashback to Math 2. This whole lesson today is a flash back to Math 2. We've got 45, 45, 90 triangles. 45, 45, 90 triangles. 45, 45, 90. Do you guys remember learning about these in Math 2? Special right triangle, 45, 45, 90. You remember learning about it?
Yes, I have it in my notes.
It's from Math 2. So this is a 45-degree angle. This is a 45-degree angle. So if this had a side of 1 and this had a side of 1, does anyone remember what this side was? Why would it be the same if it's not 2. It's got a radical. It's the square root of 2. Okay, so I'm telling Miss Lopez on everyone except for Jack. All right, better luck on the other one. So this one, we've got a 30, 60, 90 triangle. So 30 degrees, 60 degrees, 90 degrees. The 30-degree side was 1. The hypotenuse was twice as long as that, and then the side that went across from the 60-degree side was the weird side. A square root of 3. That was kind of the ratio of the sides. So this was 1, 1, and root 2. This is a 1, a 2, and a root 3. Huh? They go across from the angles. So these are both across from the 45-degree angle, so they're the same. This is the hypotenuse. So that's how I knew. The 30 is the smallest side, so the 1 was across from the 30. The 2 is across from the right angle, and then the root 3 was across from the 60. So in math 2, you spend like 2 whole days going over this stuff and just like, oh, if this side is this length, what's this other length? What's this other? It's like 2. I say this because I'm teaching math 2 and I know this is what we do because I did it in the curriculum. Okay. So we use this information to fill out the unit circle. The unit circle looks like this, but it's normally not blank. It normally has numbers. So we're going to use this information to fill in the unit circle because we're going to learn where the numbers on the unit circle came from. Do you guys, does this look familiar? Have you seen a circle with all the numbers on it before? Okay, so what we're going to do, I need you to get your cell phone out. Get your cell phone out. I need you to Google unit circle. Google unit circle. Unit circle. Yep. Okay, you guys see it? Unit circle? Okay, that's the unit circle. We're going to learn where all those numbers come from, okay? So in Math 3, we don't necessarily expect you to have it memorized. By the time you get to calculus, that drawing is in your brain. You no longer get to reference it, okay? By calculus. The unit circle is not difficult to memorize because it's repetitive. There are 66 blanks on the unit circle. It is repetitive. It is not hard to memorize because there's a pattern to all of the numbers, and we're going to see what the pattern is, okay? Put your cell phones away. You are not copying it right now. We're going to go through, and we're going to see where all the numbers come from. We're going to fill it out together, okay? All right. So here's your first picture, all right? What you're going to do is you're going to draw a coordinate right here. This coordinate is x, comma, y. X, comma, y. Everyone see that? X, comma, y? Yes? Okay. And so from this coordinate, I'm going to drop a straight line down, and I'm going to make a 90-degree angle. So I just made a right triangle. The unit circle is called a unit circle. Joseph, I don't know why you're facing the opposite direction, but I need you to come back to your own group so you can face up here. Marvelous. The unit circle is called the unit circle because it has a radius of 1. So anytime you see the unit circle, you just know from here to the outer edge, that's a length of 1. So the hypotenuse of this triangle for sure is 1. Right? Okay. So if we were to label these points, this would be the origin. This would be the point 0, 0. This would be the point 0, 1. This would be the point 1, 0. This over here would be the point negative 1, 0. This would be the point 0, negative 1, because we're talking about a unit circle. So each radius of the circle is a length of 1. Does that make sense? Yes? Okay. So right here, we're going to label this as theta. That is the central angle. And in this case, theta is going to be 30 degrees. Okay? Now, because this is 30 degrees, we're going to make a ratio, we're going to compare it. Obviously, it doesn't match up with the 30, 60, 90 triangle completely, because the hypotenuse is a length of 1, it is not a length of 2. So these triangles are not the same. Do you see that? The side that is a length of 1 is supposed to be a length of 2. So what I'm going to do is I'm going to put an A on all of these and just say that these sides, I'm going to put A root 3 because it looks better than root 3A. I'm going to say that these sides are proportional to this, but they're not exactly equivalent. Does that make sense? Proportional, but not equivalent. Okay. So what I've got now is that 1 equals the 2A side. Does that make sense? 1 equals the 2A side. Would you guys agree with that? Okay. So now we want to figure out what this measure is. Okay, because that's the missing side of the triangle. So I'm going to divide by 2, divide by 2. So I get 1/2 equals A. So the 1A side, which is just A, equals 1/2. So this is a measure of 1/2. Would you guys agree with that? Okay. And then the bottom side is A times the square root of 3. Everyone see that? Yes. I just said that this triangle, they're going to be proportional because they're both 30, 60, 90. I said they're not equivalent, they are proportional. Equivalent means they're exactly the same. Proportional means that they're like similar, but one's like the blown up version of the other one.
They're like, oh, look,
enlarged or reduced.
Oh, it's 2 times.
Yeah, they're not the same size, but they're similar sizes. All right, so in this one, we have an A times the square root of 3. So if our A is 1/2, A times the square root of 3 is going to be 1/2 times the square root of 3. And when I do 1/2 times the square root of 3, what do I get? No, just what do I get as a fraction? How do I write that as one fraction? I get root 3 over 2. Okay, so this side is root 3 over 2. Okay, so if we're going to write this as an x-coordinate and a y-coordinate, if we're matching this up with this point, x and y, x comma y, this side right here tells you how far left and right you are. Does everyone agree with that? This is left and right. So x equals root 3 over 2, and y equals 1/2. So we're going to say root 3 over 2, 1/2. How are your brains?
So
The 1 is because it's a unit circle, so it has a radius of 1.
just trying to understand this stuff.
So what questions do we have? Yes, James.
Are they going to make it so you find where it's not extend at an angle? Like, it's not going to be the precise formula, 31.
Nope. Well, that's SOHCAHTOA. That's what we did the other day. Okay. The unit circle is 30, 60, or 45. Okay. Any other questions about this? Where the numbers came from? It's not 30%, it's 30 degrees. It's the 30, 60, 90. Okay. So what we're going to do is we're going to grab our unit circle, and we're going to label that this is 30 degrees right here. and that it was an x coordinate of root 3 over 2 and a y coordinate of 1/2. Everyone good with that? Okay. All right. So here's the next one. We're going to draw a dot right here. This has an x coordinate and a y coordinate. We're going to draw a line straight down. Nope, you're going to go straight down, always straight down.
So we always want to make it 90 degrees?
Yep. Because they call this right triangle trig. These are right triangles, special right triangles. This time, if you were to measure it, this is a 60-degree angle. It's still a unit circle, which means the radius is still 1. So if you were to do these other points, this is still the point 1, 0. This is still the point 0, 1. This is still the point negative 1, 0. This is still the point 0, negative 1. So that stuff has not changed. Okay. So this side is going to be our x side. This side is going to be our y side. So if you look at this, we are still doing a 30, 60, 90 triangle. It's just oriented differently. So when we compare these two triangles, they are oriented exactly the same. You guys see that? The hypotenuse is in the same spot. The 30-degree angle's in the same spot. The 60-degree angle's in the same spot. The short side, the long leg, they're all in the same spot. Okay? These triangles are technically the same, they're just oriented differently. It's just been flipped on its side. Okay? All right. So again, we have a hypotenuse that is a length of 1. So I'm going to say the length of 1 is the same as this one up here, where it's a length of 2a. So I'm going to set 1 equal to 2a. Those sides are the same. So I'm going to say 1 equals 2a. You guys see that? The hypotenuse is the same as the hypotenuse. Make sense? Okay. So now I'm going to solve for a. The reason I'm solving for a is because if this is like my triangle where my formulas come from, I made all of the sides in terms of a. So if I figure out what a is, then I can figure out what my other sides are. Okay? So I'm going to say 1 equals 2a. I'll divide by 2. And again, I get 1/2 equals a, which makes sense because it's the same triangle as before, it's just oriented differently. Does that make sense? Same triangle as before, it's just oriented differently. It's just going to be true for these two because we did 30 and 60 and they come from the same triangle. 30, 60, 90 triangle, I'm using the same formulas. So it's going to be true for the ones that are from a 30, 60, 90. So once I switch to 45, it's going to be different because I'll be using a different triangle. Yeah, we're going to switch today. It'll be okay. It'll be okay. All right. So I get 1/2 equals a. So now, when I look at the short side, what do you guys see is the formula for the short side? 1a. Okay, so when I look at the short side, what's the length of x? It's just 1/2 because a equals 1/2. Okay? The length of the long leg is a times the square root of 3. And so we're going to take our a value, which is 1/2, and we're going to do 1/2 times the square root of 3, and what does that give us? Square root of 3 over 2, right? We write that as a fraction. And then that's going to be the length of our long leg. Okay? So this coordinate is 1/2. 1/2 for the x value. And then square root of 3 over 2 for the y coordinate. So similar to the last one, but they switch places. It's the length of the side and the point. Because see what we did? We went right 1/2, up root 3 over 2. It's on the axis, it's creating the triangle, but it's also giving us our points. So right 1/2, up root 3 over 2 to get to the point. So it's creating the triangle, and then it's giving us our points. Okay, so let's go over here. 60 degrees is right here. So we skip the one in the middle. 60 degrees is right here. 1/2 root 3 over 2. All right. Okay, turn to the next page. All right, this one is smack dab in the middle. Right here, this is smack dab in the middle. So if the whole thing is a 90-degree angle and you're cutting it right in the middle, what is it? 45. Okay, so we're going to do the same thing, put a dot, draw the line straight down, make a 90-degree angle. Okay, we're going to put the 1 for the hypotenuse because this is a unit circle. So we're going to have an x-coordinate, a y-coordinate. We got 0, 1. We got 1, 0. We've got 0, -1. -1, 0. Okay. So this time, the 1 is not on the root 2 side. And I'm going to put A's for all of these just like I did on the other one, because these triangles are not equivalent. They're similar, but they're not equivalent. So they're proportional to each other, but they're not the same. So I can see that the 1 is the same as the A root 2 side. Does everyone see that? That's the side that it is corresponding to. So I want to figure out what A is, because if I can figure out what A is, then I know what the other two sides are, and they're going to be the same, because in a 45, 45, 90 triangle, you have two equal sides. It's an isosceles triangle. So the two angles are the same, the two sides are going to be the same. Okay? Any questions? Are you guys still with me? Does that make sense? Okay, what questions do you have?
I don't even know. It just makes sense. I'm like trying to think, and I'm like, what the HE double copy did?
Did you? So the question is, how much did you participate in Math 2? Because none of.
I don't even remember.
Okay, so part of it is.
I took Math 2 honors over noted, so.
So some of this, if you did not get much out of Math 2, then some of this is.
I got this question.
I'm going to move on. Okay, so we have the 1 equals the A root 2 side. So how do I solve for A? Divide by the square root of 2. So A equals 1 over square root 2. And is that the proper way to write A? No. Yeah, what's it called? We got to rationalize it. So we're going to say, nope, that is not the proper answer. We got to fix it. We're going to fix it by doing what? Multiplying it by root 2 over root 2. So this is root 2 over 2. Okay. So root 2 over 2 is what our a value is. And so if this is our a value, and we go back and we compare it with our triangle that has our formulas up here, compare it up here, then what should we label these two sides? Yeah, so I'm going to say x equals root 2 over 2, y equals root 2 over 2. See how these were both labeled as a and a? They just say a? 1. So this side we had given in the beginning because we said this whole circle is a unit circle, which means that every radius is a length of 1.
Did we just find A or did we find A?
We found a,
So then we find
and
A times
these
4 is that.
these sides are a length of a. So once we found a, that meant that we found the other sides. So we were basically done when we found a. So our x is root 2 over 2. Our y is root 2 over 2. Okay. Any questions I can answer? How are your brains? Good? Okay, so we're going to take those numbers. We're going to take the unit circle. We're going to say that this right here is 45 degrees. The middle one, 45 degrees. We got root 2 over 2. We got root 2 over 2. Okay. So we got 0 degrees down here, right? And we've got 90 degrees up here. And we've got, since this is 1, right? This is a unit circle. This is a length of 1. So this is the point 1, 0. This is the point 0, 1. Yeah. You'll see. We're getting there now. Okay, and then if this is 190, what's this? 180. Okay, what's this point right here? Okay, negative 1, 0. Okay, so that's 180. So what's down here? 270. What's the point down here? 0, negative 1. Okay, and then when you do a full circle, what degree measure is the same as 0? 360. Okay. Nope, you only have the point one time. Okay, brains are good. We got those filled in. Yeah. You'll see in a second.
Oh, that's not just like a little area.
No, we got more to fill in. All right. Okay, so from here, here's what we're going to do. We've got, if 45 is the middle, and we got 90, what's the middle between 90 and 180? 135. So if we take 90 and we say 90 plus 45 degrees, we get 135. Does that make sense? Okay, so we're going to say 135. Now 135, it's going to, because this went right root 2 over 2, up root 2 over 2, it went to the right the same amount, and up the same amount. Do you guys see that? Okay. Well, this one's in the second quadrant, so it's going to go left root 2 over 2, up root 2 over 2. Okay? So it's going to go left root 2 over 2, up root 2 over 2. You guys see that? Okay. Let's find the equivalent of that one in the next quadrant. So this one, 180 plus 45, 225. Okay, so this one is going to go left and down, so it's going to be both negatives. So it's going to be left root 2 over 2, down root 2 over 2. Okay? And then we got 270 plus 45. What's that? 315. Okay, so this is a 315 degree angle. And then how are these signs going to go? We go right and down, so we're going to do right root 2 over 2, down root 2 over 2. Okay? All right, now we got to be careful. So let's think about how the 30s work. So this is, so we've got up 30, we've got 0 degrees, we're up 30 degrees. So here, what is 30 degrees up from 180? So 30 degrees less than 180, so we got 150. Okay, so this was to the right, root 3 over 2, up 1/2. So now we're going to do to the left, root 3 over 2, up 1/2. So left, root 3 over 2, up 1/2. Okay, now this one, here's our other 30 degrees right here. So we have to go bigger, we have to go 30 degrees bigger than 180. 30 degrees bigger than 180. 210. So we're going left, root 3 over 2, down 1/2. So left, root 3 over 2, down 1/2. We comfy?
Triangle was like,
It's if you were to draw the triangle in the 4th quadrant, or in the 3rd quadrant, I mean. Now, here's what I'll say. We just did these notes. You never have to do this again. I just wanted you to know where those side links came from. Because they didn't, it's not that somebody just pulled these numbers out of the bottom of their foot. Nobody made up these numbers. They took these numbers where I showed you. They took these numbers from the triangles. Okay, trigonometry, we said trigonometry was like the study of triangles, right? So these numbers came from triangles. So now what we're doing is, you guys see, this is the part that blows my mind about trig, is we are now relating triangles and circles together, which is wild, okay? Yeah, all right. Okay, and then over here, so this is up 30. We've got from 0 up 30 degrees. Now we're going to go from 360 down 30 degrees, which would be 330, okay. And we're going right root 3 over 2 down 1/2. And you got to be very careful when you fill this out, because if you fill it out incorrectly, you're just going to get answers wrong on problems, because we're going to use this like a calculator. Okay? All right, so now we're going to do the same thing for 60. So 60 is 30 degrees smaller than 90. So 30 degrees bigger than 90 is 120. So here we had right 1/2 up root 3 over 2. So here we're going to have left 1/2 up root 3 over 2. So left 1/2 up root 3 over 2. And then down here we have 270. What is 30 degrees smaller than 270? 240. So we have left 1/2 down root 3 over 2. Left 1/2 down root 3 over 2. And then we have 30 degrees bigger than 270. 300. And we have right 1/2 down root 3 over 2. All right, now you guys asked, what are the other blanks for? What do you think? Starts with an R.
Rational number.
Radians. We got to do our fractions, you guys. We can't forget our fractions. We need colors for this. We can't do something without colors. So pick, I always do 3 colors. Pick 3 colors. 3 colors. I'm doing these 3. My purple looks real blue.
Wait, do we need that?
Yes. This is purple.
That's purple.
It's purple, and then it's blue. And then it's purple, and then it's blue. Isn't that wild? All right. You guys ready? We're getting some colors out. Okay, now if it's gonna mess you up to do different colors than me, then you can choose the 3 colors that I chose. Why are you gonna use the bathroom while we're doing something important, man? Okay, now. Ooh, look at this. So this is purple, and this is blue. Purple, blue. Purple, blue. Purple, blue.
The blue looks the same.
The blue looks bright blue, and the purple looks blue. See, look, purple, blue. Purple.
Oh wait, the pink is darker on the camera.
Wait, how does that work?
Look at the pink.
Okay, purple and blue.
How
Blue.
does that work?
I don't know, but it's messing with me. I'm just gonna do
The
blue.
pink is brighter.
All right. You guys ready? Okay. I'm gonna start with my blue. I'm starting with blue. And what I'm doing is I'm only doing blue on the quadrant lines. I'm only doing blue on the quadrant lines. So this is my fraction. These are my fraction numbers that are going to get used over and over and over again as I count in fractions. Okay? So we are going to practice counting and fractions together. Are you ready? We've got 0 pi . Huh? I'm just doing regular pencil now. Yeah. You can do it in marker, that's fine. I'm writing all my numbers in pencil because I think they're easier to write in pencil than they are in pen. So I'm drawing my lines in marker, but I'm still writing in pencil. So I've got 0 pi, 1 pi, and then 2 pi. So 0 pi, 1 pi, 2 pi. 0, 1, 2. 0, 1, 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pi. That's how coterminal angles work. You can make a dance out of it. All right. Now, are you ready to count by halves? All right. 0 pi. Pi halves. 1 half. 2 halves. but I already wrote the number, so I'm not going to write it again. 3 halves. Oops, sorry. 3 halves. This is 3 halves. This is 4 halves, but I already wrote a number there, so I'm not going to write again. Okay? So we got 1 halves, 2 halves, 3 halves, 4 halves. See how the fractions work? 1 halves, 2 halves, 3 halves, 4 halves. Okay. All right, you guys ready for fourths? Okay, I'm going to use my green. Okay, now when I do this one, I still count on the blue, okay? I still count on the blue. Okay, you guys ready? All right. So I'm going to write on the green because the green is new, but I'm still counting on the blue because the blue still is part of the fractions, okay? So I've got 1/4. I got 1/4. 2/4. Do you guys agree that this is 2/4? Yeah? Okay. 3/4. 4/4. Do you guys agree? Yeah? Agree? 4/4? Okay. 5/4. 5/4. 6/4 down here. Do you guys agree? This is 6/4. 6/4. 7/4. And then up here we're 8/4. You guys agree? Okay. So we had 1/4, 2/4, 3/4, 4/4, 5/4. 2/4 is right here. 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Does that make sense? Okay. Okay. Cool. Okay. The rest are going to be all pink. Okay? Whew. Now, we're going to have to be careful as we do these ones to simplify as we go. Okay? Now, when we do these ones, we're going to count purple and blue, but we're not going to count green. We're going to count purple and blue. So remember how I said blue gets included every time? Blue gets included every time, okay? So we're counting pink and blue, but we're not counting green, okay? Or purple. It could be purple for you. Okay. So how many, what fraction are we counting if you count these? Because this is a whole, right? It's from 0 to pi, so it's a whole. It's 6. We're not counting green, remember? So 6, okay? So we got 6, but we're going to have to be careful. We're going to have to do a little bit of simplifying as we go, okay? Are you ready? All right, here's the first one. We got 1/6. Okay, this one, don't just automatically write it down because we're going to have to simplify it. We got 2/6, which is 1/3. Okay, we can write that down. This is 1/3. 2/6, which is 1/3. Then we got 3/6. We already wrote that one down. Is that 3/6? Is this 3/6? 3/6, okay. Then we got 4/6, which we're going to simplify before we write it down. 2/3. Then we got 5/6, which is just 5/6. And then we got 6/6, which we already wrote down. You guys agree this is 6/6? Yeah. Okay, let's start on the other half. Now, we got 7/6, We got 8/6, which is 4/3. We got 9/6. Is that right? 9/6. 3, 9/6. 3.
It goes into 3/3. No, that's 1. So I gotta add more.
The mental math here is outstanding. So if we had 9/6, that's going to be 3/2. 3/2, which is what we have. Whew, okay. So 9/6 is 3/2. That's good. Okay, then we had 8/6, 9/6, 10/6. 5/3. Okay. 10/6. Okay, and then we got 11/6. And then we have 12/6. Is 12/6 the same as 2? Marvelous. Okay. Now, what's cool? Are you guys ready? You can count your thirds too. Let me show you your thirds. Ready? 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Okay? So here's how this all works. Okay? Here's how I memorize my unit circle. Okay? I think of it this way. Are you listening? Okay. I remember that 3 is bigger than 1. Would you guys agree with that? 3 is bigger than 1? Root 3 is still bigger than 1. Root 3 is bigger than root 2. Yeah, so I just remember that, okay? So here's how I remember these numbers. Are you listening? Here's how I remember these numbers. I think this point, I have a whole lot of people not looking up. For this point, I think it's right a lot, up a little bit. You guys see that? Root 3 and then 1. Right a lot, up a little bit. And then over the same amount, up the same amount, the root 2 over 2, root 2 over 2. And then over a little bit, up a lot. Does that make sense, how I get the numbers in there? So I do it by the size. Right a lot, up a little bit. 3 and then 1. Right a lot, up a little bit. Same, a little bit, a lot. Does that make sense? And I can do that for the x and the y all the way around the circle. I think the degrees are the easiest part. And then I do the fractions the way I just showed you. That's how I have memorized the unit circle. What you do, the best strategy, is to just print a bunch of blank ones and do it over and over and over and over again until you have it memorized. So, but it does work. I'm telling you this because it sounds like a lot of work. By the time you get to calculus, you can no longer have this page in front of you. You guys will in Math 3. There are some EOC questions that lead me to believe they expect you to have it memorized. There are some EOC questions where they will give you just the x and the y. We call that like the coordinate pair. They'll give you just the coordinate pair and they'll expect you to know the degree measure. So there's variations of what they expect you to have. Yes, Joseph. I am not going to make you memorize it. We will look at the types of EOC questions. Okay, we're going to go back to our notes. All right. So here's what your notes say. Remember SOHCAHTOA? We remember SOHCAHTOA?
The lady who got fired for dancing.
Yes, we do. We do remember that. Okay. So here's what I want you to do. You can trace this from the other page actually, if you want.
I don't know which one we do.
I'm tracing one of the samples from the previous page. It doesn't matter now. Okay. It just looks a little bit nicer if you trace it. Okay. So go ahead and draw something that looks like that. I'm going to staple your face if you don't put that stapler away. If you guys break my brand new stapler, we're gonna have issues. All right. So everyone should be drawing a sketch like this on their notes. Are we drawing? Yes. Okay. So we know that 1 is the hypotenuse. If this is the angle, what is the name of the y side? Opposite. Okay. What's the name of the x side? Adjacent. Okay. All right. So over here, it says, hey, remember sine, it's opposite over hypotenuse. But in terms of the unit circle, opposite over hypotenuse is actually y over 1. Would you guys agree with that? See, because this side is up and down, and the unit circle always has a radius of 1, and the hypotenuse is the radius. So it's always going to be y over 1 only on the unit circle. Okay? So we're going to say, for the unit circle, it is y over 1. Anything over 1 is just itself, right? Okay, so sine actually corresponds to the y-coordinate of all the points. The y-coordinate, if we look at the unit circle, all the y-coordinates, those correspond to sine. Okay, so I'm going to show you something that's kind of interesting here. We're going to say, so I'm going to see my calculators in degrees. So I'm going to say, hey, calculator, what is sine of 135? And my calculator is going to say, hey, it's root 2 over 2. You guys see that? Sine of 135 is root 2 over 2. I'm going to say, hey, calculator, what's sine of 210? And my calculator is going to say, hey, it's negative 1/2. I'm going to say, hey, calculator, what is sine of 0 degrees? My calculator is going to say it's 0. Sine of 0 degrees is 0. Does that make sense? So whatever degree measure I plug in, if I do sine of that degree measure, my calculator is going to pop out the y-coordinate. Does that make sense? Okay, because that's how the unit circle works. All right, now I'm going to say cos of theta is adjacent over hypotenuse. What's the adjacent side? X over 1. So that's just x. Okay. All right, so same thing here. If I want to know what cos of 315 is on my calculator, it's actually just going to be this x coordinate. That's how we're going to use the unit circle like a calculator. Does that make sense? So my calculator is limited. It can only give me decimals. My unit circle is not limited. It can give me exact answers, where my calculator cannot. Does that make sense? Marvelous. Okay. Tangent. Tangent is opposite over adjacent. So what are those two sides? Y over x. But we literally just redefined what y was. What did we define y as? We just defined y as sine. And we just defined x as what? Cosine. So tangent is actually sine divided by cos. So in the unit circle, we know that the x corresponds to the cos, the y corresponds to the sine. We know that tangent, we're actually going to write this on our unit circle because this is really interesting stuff to us. So we're going to say that x comma y, we're writing this on our unit circle. X comma y is the same as cos comma sine. And I remember this by saying that this is like alphabetical. The x corresponds to cos. X comes first in the alphabet, so does cos. Y comes second in the alphabet, so does sine. And then I remember that tan is sine over cos, aka tan is y over x. All right, so here are going to be some examples of that. Put your unit circle in front of you. We're going to use it like a calculator. Example 1. We're going to find sine of pi thirds. So what you do first is you look on the unit circle and you locate pi thirds. And then because sine is the y-coordinate, you're going to find the y-coordinate at pi thirds. So what is the y-coordinate? So you're going to say this equals square root 3 over 2. All right, example 2. We're going to do cos of 5 pi fourths. So you're going to look for 5 pi fourths on the unit circle. And you're going to find the x-coordinate, because this is cos. And so what is cos of 5 pi fourths? Negative root 2 over 2. All right. All right, we're going to do tan of 2 pi thirds. Tan of 2 pi thirds. So for this one, you're going to locate 2 pi thirds. And then we're going to take the y-coordinate, and we're going to take the x-coordinate, and we're going to divide them. So we're going to take the y-coordinate first, which is what? The y-coordinate, root 3 over 2. And the x-coordinate, which is negative 1/2. And how do you divide two fractions?
Multiply. I'll just say the denominator.
You keep, change, flip, right? Keep it, change it, flip it. So we're going to say we've got root 3 over 2 times negative 2 over 1. Would you guys agree with that? Now what happens with the 2's?
They cancel.
The 2's are going to cancel. So my strategy whenever I do tan is I ignore the 2's. I ignore the 2's on the bottom. Do you guys see that? Because the 2's are going to cancel every time. So I ignore the 2's. I pretend that the 2's are not there. I only look at the top. Does that make sense? It'll make it go faster. So when I look at 2 pi thirds in my head, I go root 3 divided by negative 1. You guys see that on your unit circle? In my head, I ignore the 2's because I know they're going to cancel. I do root 3 divided by negative 1. So what is root 3 divided by negative 1? Negative root 3, that's the answer. Does that make sense? The 2's canceled, not the negative. There's only one negative sign, so it couldn't cancel. Had to stay. All right, let's do another tan one. We're going to do tan 315 degrees. Tan 315 degrees. Tan 315 degrees.
Oh, shoot, so we just basically go and find it.
Oh.
It's y divided by x. Y divided by x.
3 over 2.
It would be negative 1. Because the y and the x are the same number.
Oh.
Oh, it's negative 1 because the y and the x are the same number. All right. All right, we're going to do We're gonna do cosecant. Do you guys remember cosecant? Cosecant of 150 degrees. So how does cosecant work?
It's the opposite.
What do you mean by opposite? Yeah, so you take sine and you flip it. So if it's 150 degrees, we're taking sine, which means what coordinate we're using? Wait, which coordinate? Y. Cosecant goes with sine, so it's the y coordinate. So we're going to take the y coordinate and we're going to flip the fraction. So take 150 degrees, look at the y coordinate, look at the y coordinate, flip the fraction. It's 2. Does that make sense? So all we had to do is we had to look at the y coordinate, flip the fraction. Okay, so there's a worksheet for you guys to work on today. Yes. This is what you guys are working on today. This is all we are doing tomorrow, is practicing reading the unit circle. That's all we are doing tomorrow. Yes. This worksheet is homework tonight. There's a new thing to print for tomorrow. Yeah. Yes. It's on Canvas. It's already up. Yep. All right. No. You'll just turn it in on Monday when we come back. All right. Yes. You guys are turning in. Here you go. Walker. Here you go. Oh, I just have one for you and Walker. Yeah. All right. Go ahead and get started. Lost what? Just doing the worksheet?
No. Like ending to 150. I didn't control answers.
2?
Oh, really?
You're still recording.
Let me stop it.